Next, we're going to introduce briefly how to do the frequency analysis in MATLAB. This is definition for the frequency response of the continuous time LTI system. So what we need is the coefficients from the differential equation. And in MATLAB, we have the frequency response function for the continuous time system. This is a function can be used to help us determine the frequency response. These two are the coefficient vectors on the numerator or the denominator respectively. And this is parameter tells us at which frequency we need to evaluate the frequency response. And here's one example how we can make use of that function. We have a frequency response defined in here for a continuous time LTI system. And these are the coefficients. And we're asking you please sketch the amplitude response of the system and try to determine the response of the system to the signal in a given file. For the first question, it's quite straightforward. We get the coefficient vector and put them into the frequency response function, and we get the frequency response, and we try to use the ABS, get the amplitude response. And here's the graphic representation. The second question is, we get the system. This is a transfer function of the system. And then we read the signal from this file out. Now we can use this LSIM to get the response of the system specified here to the signal we read from this file to get the final results. And the sound can play back the resulting signal. And if this is the input, you may hear there's some noise inside it. And if that signal spectrum shown in here passing through this low pass filter, you may see the noise part will be filtered out. And here is the resulting signal. Apparently, the noise is moved out. For the discrete time LTI system, similarly, we have this function to help us determine the system's frequency response. And again, A and B are the coefficient vectors. And this is the number of frequency or the frequencies we try to evaluate the frequency response. And here's one example. We have a discrete time LTI system, and here are the coefficients. Two questions. One is, please sketch the amplitude response of the system. Second is, what is the system's response to the signal in this file? Again, the first one is quite straightforward. We can using this function to get the system's frequency response. And here is the amplitude response. And we can get the signal from the file and then use this function for discrete time LTI system to get the response of the system to the input signal. And we can play the resulting signal back. And here is the input signal. The noise is identified as this spike, and that spike can be filtered out using this band stop filter. And here is the resulting signal. apparently the noise is removed. Thank you.